हेलो नहीं तो पता नहीं मेरे पास में है। Okay, so today's topic is thermal expansion. In thermal expansion, we will discuss that any material on heating can expand, and we will try to measure the expansion in that material. It may be linear, it may be superficial, that is in 2D, in the form of a plate, or it may be volumetric, that is in 3D. So thermal expansion is the expansion in the matter due to heating. Due to heating. And during expansion, there are certain features of the matter which are not going to change, and there are certain properties which will change. For example, if you are looking for the mass of the matter is independent of temperature, hence there will be no change in mass of the matter during thermal expansion. So mass is not going to change. No change. Mass will be constant. Apart from mass, if you will look at the density is given by mass by volume, right? Since temperature is increasing and matter is expanding, which implies that volume will increase, but mass is constant, mass is not going to change. So this clearly indicates that density d or rho, which is given by mass by volume, will definitely change, because mass is not changing but volume is changing. And from this formula, density is inversely related with volume, which states that if volume is increasing, density will decrease. So thermal expansion means this is an expansion in matter on heating, and during the expansion, dimensions of the matter will change, which means volume or surface area or length of the matter will change. And due to this expansion, density of the material will decrease, but there will be no change in mass of the material or the matter which is given to us. Understood or any doubt in it?
डाउट।
Yes.
सर आपने बोला टेम्परेचर बढ़ेगा तो वॉल्यूम बढ़ेगा।
Yes.
सर कैसे?
Okay. Let's say we have we have three different cases in it, which will be in 1D, in 2D, in 3D. In 1D, it is known as linear expansion. In 2D, we call it as superficial expansion, or you can also write it as areal expansion. In 3D, we call it volumetric expansion. Now, if you will take the example of linear expansion, so what will happen in linear expansion? In linear expansion, I have a rod of a material of certain length, and this rod is in such a way that its thickness is way smaller than its length, which implies that you can ignore the thickness of the material in this case. That's why we are calling it linear and 1D. Otherwise, it has to be 2D, because there has to be some width definitely. But we are saying that the length of the material or length of the wire or conductor or rod is very high or very large as compared to its thickness. And now I will heat it with the help of a burner. So what will happen in this process? When we will heat the rod, then some of the heat energy will be transferred to the material. And when we are saying that some of the heat energy is transferred to the material, it means that heat energy is given to the constituent particles of the material. So at any temperature, there will be certain energy for the constituent particle, which is known as thermal energy of the particle or kinetic energy, in other words. Now, if you will increase the temperature, if you will heat it, the energy of constituent particles, that is kinetic energy, will increase. So what do you think? If the kinetic energy is increasing, what will happen to the constituent particles? Will they come close or they will try to go away from each other? What do you think?
They will try to go away from each other.
They will try to go away from each other, which clearly implies that in this case, there has to be some expansion, because the constituent particles are moving away from each other. So there is certain expansion in it. And this expansion will be in both the direction. Again, I am saying it is in 1D. So I am not talking about y-axis. It is happening in x-axis only. But road has two direction of x-axis, positive direction and negative direction. So this expansion will be in both direction, in positive direction as well as in negative direction. Let me call it delta L1, that is change in length in positive direction, and delta L2, that is change in length in negative direction. Now, if you will calculate overall change, we write it as delta L. In book, delta L1 and delta L2 is not given. It is simply delta L. But remember, delta L does not imply the expansion in only one direction. Delta L is basically the overall expansion, which may be in positive direction as well as in negative direction. So delta L is equals to delta L1 plus delta L2. In this discussion, we are not interested in delta L1 plus delta L2. We are simply interested in overall expansion, which is delta L. It means I am not going to calculate delta L1 and delta L2 separately, but we will calculate delta L in a single shot, or overall delta L. So according to experiment, it is shown that delta L is directly proportional to delta T. And it is obvious, greater will be the temperature difference, greater will be change in the length of the rod. Second factor is delta L is directly proportional original length of the material or rod. Greater will be the length, greater will be the change. If you will club these two factors, it will be, or let me just explain it a little bit. First factor is delta L is directly proportional L, which implies that if you are having a rod with greater length, changes will be greater, and for smaller length, changes will be small. Second factor is temperature. Delta L is directly proportional to delta T. Remember, it's not T, it's delta T, which implies that you have to check the difference in temperature or change in temperature, and which implies that greater will be change in dimension, and if there is less difference in temperature, length will be changed by a small amount. If you will club these two factors, you will get delta L directly proportional L delta T, and on removing the proportionality, we have a constant delta L is equals to alpha L delta T. So this is the formula for linear expansion, and here we have a special constant, that is alpha. We call it as what? We call it as coefficient of linear expansion. Are you getting it or any doubt in it? Yes, any doubt? Okay. So you must have the information what is delta L, what is alpha, what is L, and what is delta T. Let me recap it again. L is the original length of the material or rod, and alpha is the coefficient of linear expansion, which will be a constant value for the material. If you will change the material, the value of alpha will change. Alpha is also connected with temperature, but we are not going in that detail. That will not be the question there. But alpha is dependent on temperature as well as on nature. That is true. Now we have delta L. Delta L is what? Delta L is change in length. In some book we write it as delta L is L final minus L initial, which is equals to alpha L delta T. And in this case, L is Li, initial length. So if you are interested in finding the final length of the road, it will be L final equals to L initial plus alpha L initial delta T, which means L final will be L initial times 1 plus alpha delta T. So this is also the way to represent the same concept. Understood or any doubt? Yes, understood or any doubt? Okay. Okay, so now let's first of all, is the doubt clear that why the material is expanding? There was a question.
Yes, sir. Clear.
Okay. Now we have superficial expansion. Superficial expansion, or I will call it as expansion in 2D. Superficial expansion or expansion in 2D. 2D indicates that in this case expansion will be in both the direction, in x-axis as well as in y-axis. And we explain it in this way. Let's say I have a plate in square form or rectangular form which has certain area A initial, and then we heat it. And on heating, all the dimensions will change, whether they are along the x-axis or along the y-axis. The dimensions will change, and in this case they will expand. So the new arrangement will be something like this. There will be expansion in x direction as well as there will be expansion in y direction. Again, I am not interested in the calculation of individual expansion in x direction or y direction, but I am interested in overall change in area of the material. So after expansion, there has to be a different area. Let's say that area is A final. So change in area will be delta A, which will be A final minus A initial. Now again from experiment, it is proved that delta A is directly proportional to A, which simply means greater will be the original area, greater will be expansion in the plate, or smaller area, smaller expansion. Another factor is again delta T. Delta is directly proportional to delta T. Again, the case is same. Greater change in temperature, greater change in area, smaller change in temperature, smaller change in area. If you will club these two factors, you will get delta A directly proportional A delta T. And on the elimination of proportionality, we will have a constant here, proportionality constant, which is given by beta this time. So this will be delta is equals to beta A delta T. This is the mathematical formulation for superficial expansion or expansion in 2D in any material. And when we are talking about the expansion in 2D in any material, it means we are ignoring the height of the material. Like if we have a rectangular plate, there has to be some height of that plate. But other dimensions of the plate, that is length and breadth, are very large or very high as compared to its height. So we are ignoring height of the plate in this case. Now, what do we call beta? So in this case, beta will be coefficient of aerial expansion or superficial expansion. Understood or any doubt? Okay, another format will be delta A is equals to A final minus A initial, which is equals to beta A initial delta T. So you can find out A final, which will be A initial times 1 plus beta delta T. Understood or any doubt? Okay. Next we have expansion in 3D, that is volumetric expansion. Volumetric expansion or expansion in 3D. In this case, we have a cube or a cuboid or any other material in 3D which has significant length, breadth, and height. And we cannot ignore neither of the three. We cannot ignore length of the material, we cannot ignore height as well as breadth of the material. So we have to take into account all the three dimensions in this case. That's why we are calling it expansion in 3D or volumetric expansion. Again, let's say its original volume is something V, and after expansion its volume will change. So let's say this is the expansion in the material. So this is V final. There will be certain change in the volume given by V final minus V initial. And if we will look at the factors affecting delta V, it will be V by the same rule. Greater V, greater will be change, smaller V, smaller will be change. Another factor is again temperature. Delta V is directly proportional delta T. Greater the temperature variation, greater will be change in volume. Smaller temperature variation, smaller variation in volume. If you will club both the factors, you will get delta V directly proportional V delta T. And on removing the proportionality constant, sorry, proportionality, we have a constant. And this time constant is gamma V delta T. And in this case, gamma is a proportionality constant which is known as coefficient of uh, volume expansion. Again, we can write it as delta V is V final minus V initial, which will be equals to gamma times V initial delta T. So V final can be given as V initial times 1 plus gamma delta T. In this formula, it may occur to you that the temperature variation is in such a way that the dimensions are increasing, but it can also be in opposite way, which means it is also possible that someone will decrease the temperature of the material instead increasing. So if you will decrease the temperature of a straight rod, in that case its height will decrease, and in that case L final will be smaller as compared to L initial, and there will be a factor of delta T with negative sign because final temperature is smaller than initial temperature and delta T is temperature difference. So if you will include proper sign convention, you will get delta T less than 0, which implies that we are decreasing the temperature, and in that case change in length will also come out with minus sign, which again implies that there is negative increment or there is a decrement in the length. Are you getting it or any doubt? Now there is an interesting relation between alpha, beta and gamma. Alpha, beta and gamma, which is very famous and given by alpha is to beta is to gamma, which is 1 is to 2 is to 3, which implies that if you are looking for the value of beta, that will be twice of alpha, and value of gamma will be 3 times of alpha, which means you can write it as 3/2 beta also. From the above expression, if you will find out alpha, this will be beta/2. And by putting alpha in gamma is equals to 3 alpha, you will get 3/2 beta. So these are the relations between alpha, beta, and gamma. Could you explain what does it mean alpha is to beta is to gamma is 1 is to 2 is to 3? Yes. Could anyone explain me the physical meaning of this statement alpha is to beta is to gamma is 1 is to 2 is to 3?
They are in ratios.
Sir, 1D, 2D, 3D.
Yeah. What does it mean in physical sense? In physical sense or in physical world, it means the expansion in 2D is faster than expansion in 1D, which means if you want to expand a material, you should convert it into 2D sheet rather than a single 1D road. Are you getting my point?
Yes, sir.
Yes, sir.
Okay. There is one more interesting concept in this chapter, which is known as anomalous behavior of water. On heating, generally matter expands. But in case of water, there is something different, which is known as anomalous behavior of water. Anomalous behavior of water means it is not behaving in the same way as other liquids do. So what is the behavior? But before that, let me explain about the unit and dimension of alpha, beta, and gamma. I just forgot. If you will find out the formula of alpha, then it will be, if you will look here, what will be alpha? Alpha will be delta L divided by L delta T. So this will be delta L divided by L delta T. And if you will look for beta, in the similar way, this will be delta A divided by A delta T. And in case of gamma, this will be delta V divided by V delta T. So if you will look at the unit for the alpha, so you know delta L is a length, and in denominator we have length. So unit of length will cancel out by unit of length, which means we are left with unit of temperature. So unit of alpha, beta, or gamma will be unit of temperature inverse. If you are taking temperature in degree Celsius, it will be degree Celsius inverse. Or if you are taking it in Kelvin, it will be Kelvin inverse. But if the question is what is the SI unit of alpha, beta, or gamma, then in case of SI unit, it has to be Kelvin inverse. Otherwise, we can say that unit of alpha, beta, or gamma may be Kelvin inverse as well as degree Celsius inverse or Fahrenheit inverse. But in case of SI unit, it will be definitely Kelvin inverse. What will be the dimension? Again, L factor will cancel out, area A will cancel out, and volume will cancel out. So we are left with again temperature. So in that case, dimension will be, for temperature we have T. So dimension will be T inverse. Sorry, I think for time we have T. T is for time, not for temperature. For temperature we have either theta inverse or we have Kelvin inverse. So in some book we write it as K inverse. Understood or any doubt?
Understood, sir.
Okay, next
सर
is
क्वेश्चन कैसे आएंगे?
क्वेश्चन अभी कराता. Next is anomalous behavior. And important point in anomalous behavior of water is that if you will heat water between 0 degrees Celsius to 4 degrees Celsius, basically on heating, I already told you in the starting of the session that on heating material will expand. But in case of water, this is opposite. In case of water, if you are heating the water and the temperature is changing in between 0 to 4, in that case, instead of expansion, there will be contraction in the water. So it will contract. And after 4 degrees Celsius, if you are still heating it and the temperature is going to be greater than 4 degrees Celsius, in that case, it will expand. So in this case, it will be expansion. So the interesting point is 0 to 4 degree variation and what is going to happen at 4 degrees Celsius. So on heating water, first water contract and then water expands. Contraction takes place in between 0 to 4 and it is greater than 4. Density is given by mass by volume and we already discussed that mass is not going to change on changing of temperature. Mass is going to be constant. So we are left with density and volume. Density is inversely related with volume. Now, if we will look at the behavior of water in between 0 to 4 degrees Celsius, in between 0 to 4 degrees Celsius, water is contracting, which means at 4 degrees Celsius, volume of the water will be minimum. And if volume will be minimum, this implies that density is going to be maximum. So at what temperature density of the water is maximum? The density of the water is maximum at 4 degrees Celsius and that density is taken as a reference density of the water. So when we say density of water, it is the density of water at 4 degrees Celsius. This statement also implies that density of the matter is not constant. Density of the matter or material is connected with temperature. A single material or matter can have different density at different temperature. As you will change the temperature, accordingly density will also change. So at what temperature water has the maximum density? It will have maximum density at 4 degrees Celsius, since at 4 degrees Celsius the contraction will be maximum and volume of the water will be minimum. Understood or any doubt?
Sir, can you elaborate with example?
With example means?
Means so I can get idea how its expansion is going on.
Basically, it will be connected to the chemical arrangement of the molecules in water. At if you look at the temperature at 0 degrees Celsius, it will be in the form of ice. Yes or no?
Yes, sir.
And in ice, there are some gaps, holes, which are filled with air. Yes?
So basically it will melt after 4
Yes. Yes. And in that case, the gap which was due to the presence of holes and air, that will be filled with water. So there will be no further increment. In fact, already presented space will be filled with water. Are you getting it?
Got it, sir.
The question will be, what is the proper plot for density and temperature or volume and temperature for water? And the graph will go like this. Let's say here we have temperature and here we have volume. So what will be the behavior of the graph? If this temperature is 0, so volume has to be somewhere. And let's say this is 4 degrees Celsius, and after 4 degrees Celsius again we have temperature variation. So the graph goes like this. And at 4 degrees Celsius, volume of the water is minimum. At 4 degrees Celsius it is minimum, V minimum. And in case of density, the graph will be opposite. Let's say this is temperature and here we have density. This is 0 degrees Celsius. At 0 degrees Celsius, there will be certain density of the material, water. And then we have 4 degrees Celsius, and then again we have different temperature scale. And what will happen here is that when we will increase the temperature between 0 to 4, volume will decrease, which means density will increase, and it will peak its value at 4 degrees Celsius. And after 4 degrees Celsius, there will be further increment. After 4 degrees Celsius, there will be increment in the volume, and due to which density will go down and the graph will be like this. Interesting point is, in between 0 to 4, volume is decreasing. Which implies that in between 0 to 4, there is contraction in the water. And at 4 degrees Celsius, contraction is maximum possible. And after 4 degrees Celsius, it is further increasing. Volume is increasing, which means now it starts expanding again. So after 4 degrees Celsius, there is expansion. Similarly, in 0 to 4 degrees Celsius, due to contraction, density will increase. And after 4 degrees Celsius, which means in this temperature range, density will decrease. Understood? Question will be straightforward, data will be given. You just have to apply the formula. For example, question is, I'm not writing the language, I'm just reading it. A blacksmith fixes an iron ring on the rim. There is an iron ring and there is a rim. This is ring. This is rim of the wheel of a horse cart. The diameter of the rim, this is rim, its diameter is, the diameter of the rim is 5.243 meter, and the diameter of the ring, this one, diameter D of the ring, is 5231, respectively at 27 degrees Celsius. 27 degrees Celsius. To what temperature should the ring be heated so as to fit the rim of the wheel? From the data, it is clear that the dimension of ring is smaller than rim, which implies that there is no way that ring will fit on the rim. So what we are trying to do here is that we will give some heat energy to the ring, and due to the heating, ring will expand in such a way that it will be fit on the rim. Now the question is, to what temperature I have to heat it? Definitely I cannot heat it for any amount of time, or I cannot give it any amount of heat energy, right? It may melt also. So I have to be careful about the temperature at which it should be heated so that it can fit on the rim. So for that, what will we do? We will try to find out change in dimension, that is delta L. Delta L, which is given by L alpha delta T. Am I right? Or L final is equals to L initial 1 plus alpha delta T. This is also a way to say the same thing. Yes or no? So in this case, what I want to do is that I want to have final length 5.243 meter and initial length is 5.231. In bracket 1 plus alpha, we have the value of alpha. Alpha will be given into the question. And for the material, alpha is 1.20 times 10 raised to power minus 5 into change in temperature, that is delta T. So I am interested in the temperature. If you will arrange it, you will get the value of delta T. So this will be 5.243 divided by 5.231 is equals to 1 plus 1.20 into 10 raised to power minus 5 in bracket. Delta T is T final minus T initial. Let's say T final is T minus T initial is 27. On simplification, you will get the answer. So if you will simplify it, this will be 5.243 minus 5.231 divided by 5.231 is equals to 1.20 into 10 raised to power minus 5 T minus 27. So T minus 27 can be given as, what is the difference of 5.243 and 5.231? Could you subtract it for me fast? 5
Zero,
point, yes,
zero, 0.012.
0.012
2.
divided by 5.231, and this factor will come into the denominator 1.20 times 10 raised to power minus 5. Now you can simplify it. So this will be T minus 27 is equals to, I think, you can write it as 30, and you can write it as 20. 10 will cancel out, 12 will cancel out, 10 will again cancel out. So we are left with 1 upon 5.231 into 10 raised to power minus 3, which is nothing but 1000 divided by 5.231. So on calculation, temperature T final will be 218 degree Celsius. Understood? So this type of question will be there. Question will not be in too much detail. Question will be straightforward. You have to know the concept. You must learn formula, then you can directly apply it. Understood? Is the screen visible
Yes, sir.
and
Yes,
it's
sir.
working?
Yes, sir.
ओके, केमिस्ट्री में क्या करेंगे हम आज? IUPAC name is done, right? Yes or no?
Yes, sir.
Okay. Hello alkanes and hello arenes. Have you done this chapter? Yes or no? Have you done the organic reactions?
No, sir.
Okay. In chemistry, there are lots of reactions in organic chemistry. Okay. Let's say first reaction is halogenation. In this reaction, we have RH, that is alkane, and it will be treated with halogen X2 in the presence of sunlight or ultraviolet radiation. So what will happen in the reaction? H atom will be replaced by halogen atom Rx. The reaction goes like R bond H plus halogen is X bond X, ultraviolet radiation or sunlight, HX will come out of the reaction as byproduct, and we are left with Rx plus HX. Rx is known as alkyl halide. Are you getting it? Rx is alkyl halide. Let's say we have CH4 treated with Cl2, the presence of sunlight. So this will be CH3Cl plus HCl. If it is CH3CH3 reaction with Cl2 sunlight, this will be CH3CH2Cl. Interesting point is if we have CH3CH2CH3 and Cl2, Now there are two types of carbon in this compound. One of the carbon is of 1 degree, and another carbon is of 2 degree. Do you know the concept of degree of carbon? Yes. Do you know degree of carbon?
Yes, sir.
Okay. Degree of carbon is, how will you find out the degree of a carbon? So in this reaction, what will happen? H atom will be replaced from 1 degree carbon as well as from 2 degree carbon. So there will be two products. CH3, CH2, CH2Cl. Hydrogen is replaced from 1 degree carbon. And in another case, this will be CH3, CHCl, CH3. Hydrogen is replaced from 2 degree carbon. In this reaction, 3 degree is more prior than 2 degree than 1 degree than methyl or CH4. So if we have 3 degree carbon, 2 degree carbon and 1 degree carbon, this reaction will be fastest at 3 degree carbon, then 2 degree, then 1 degree and finally normal. Are you getting it? And there will be as much product, as much degree of carbon will be there. If you have 3 types of carbon in the compound, 1 degree, 2 degree, 3 degree, there will be 3 types of product. Product due to 1 degree carbon, product due to 2 degree carbon, and product due to 3 degree carbon. Understood?
Sir, at normal, no reaction will occur.
At
Normal.
in case of normal, like we have simplest possible CH4, the reaction will be there, but there will be only one compound, one and only one compound.
Okay, sir.
Okay. Reactivity order will be I2, Br2, Cl2 and F2. Understood? Next we have carbon double bond carbon or carbon triple bond carbon, which means alkenes or alkynes. And we want to have halogen. So there are two ways. First way is you can convert double bond or triple bond into alkane, and then you can do the first reaction on alkane. So to convert double bond or triple bond into single bond, you have to do reduction. For reduction, we have H2 oblique Ni, H2 oblique Pt, H2 oblique Pd. These are some standard reducing agent. In case of H2 oblique Ni, temperature has to be somewhat high. So in case of H2 oblique Ni, temperature will be high. In case of H2 oblique Pt and Pd, normal temperature will work. And how the reaction takes place? If we have double bond, there will be one sigma bond, one pi bond. On reduction, pi bond will be broken and hydrogen will be given on both the valency. So this will be something like this. Let's say we have carbon double bond carbon and we treated it with hydrogen H2. So what will happen in the reaction? One of the pi bond will be broken and hydrogen will attach to both the valency of carbon. So this will be carbon single bond carbon with hydrogen. Same is true for triple bond. In the first reduction, one of the pi bond will be broken and we will have CH double bond CH. If we will do again hydrogenation or reduction, again pi bond will be broken. But remember, this will break only pi bond. So this will be carbon, hydrogen, hydrogen, single bond carbon, hydrogen, hydrogen. Understood? If we have CH2 double bond CH2 and we react it with H2 oblique Ni or H2 oblique PT or PD, what will be the product? So this pi bond will be broken and the product will be CH3 bond CH3. Next we have CH triple bond CH. Reduction, one of the pi bond will be broken. So we will have CH2 double bond CH2. Then again reduction, again pi bond will be broken. And finally we have CH3 bond CH3. Once we have alkane, we can apply the concept of halogenation directly. Understood or any doubt? Yes. Or there is another way which is known as Markovnikov rule. Do you know what is Markovnikov? Yes, anyone? Markovnikov rule explain the addition reaction on unsaturated hydrocarbons, whether it is carbon double bond carbon or carbon triple bond carbon, and these unsaturated hydrocarbons are treated with such type of reagents in which one part of the reagent is positive and another part of the reagent is negative. For example, H plus halogen minus or H plus HSO4 minus or H plus OH minus. Such type of reaction can take place according to the Markovnikov's rule. And Markovnikov's rule states that in a carbon or in a unsaturated hydrocarbon, that carbon will be positive which has least number of hydrogen. So the carbon with least number of hydrogen will be positive and negative part of the attacking reagent will be attached to the positive carbon. So let's say this carbon is positive and this carbon is negative. So according to Markovnikov rule, negative part of the reagent will be attached to the positive carbon and positive part will attach to the negative carbon. And how to take the decision of sign of the carbon, which carbon will be positive, which carbon will be negative, that will be decided according to the number of hydrogen atoms. The carbon with least number of hydrogen atoms will be positive, and carbon with more number of hydrogen atom comparatively will be negative. Are you getting it?
Yes, sir.
Let's say we have CH2 double bond CH2, and we are treating it with HCl. In HCl, H is plus, Cl is minus. So in this case, the unsaturated hydrocarbon is symmetric. So there is no problem in CH2 double bond CH2. You can just break the bond. Any one of the carbon will be positive, any one of the carbon will be negative, because both of them are symmetric. Both of them have same number of hydrogen atoms. And according to the Markovnikov rule, plus will be with minus and minus will be with plus. So we will have CH3 bond CH2Cl. Am I right? Yes or no? Yes or
sir.
no? Okay, next, let's say we have one more example, which is CH3CH double bond CH2 treated with HCl. What will be the product? This is plus, this is minus. So in this case, unsaturated hydrocarbon is not symmetric. It is unsymmetric. So the carbon with least hydrogen will be positive. So this will be positive and this will be negative. So Cl minus will attack on plus and H plus will attack on minus. So we will get CH3 CHCl single bond CH3, because CH2 will get H, so it will be CH3. Or there is another condition in which negative will be connected with negative and positive will be connected with positive. This will be CH3 CH2 CH2Cl. But reaction is taking place according to Markovnikov rule, which means product according to Markovnikov rule will be measured. So this will be major product in this reaction, and this will be minor. Minor and major indicates that this will be in large amount in the solution, this will be in less amount, and in terms of percentage, this is 80%, this is 20%. Understood? Understood, yes or no? This is another example. Let me write it as double bond CH2 treated with HCl. What will be the product? So this will be CH3 CCH3 Cl CH3, or another case is CH3 CH3 and CH2Cl. In this case, this is major product, this is minor product. 80%, 20%. Understood or any doubt? Understood or any doubt? Okay. Another important reaction is anti-Markovnikov rule. Anti-Markovnikov rule is opposite of the Markovnikov rule. It also work on unsaturated hydrocarbons, single bond or double bond or triple bond. But special features of anti-Markovnikov rule is that it will work only with HBr, not with any other halide. It will not work for HCl, HI or HF, but only and only for HBr. And there is another condition: if you are taking only HBr, then the reaction will be according to Markovnikov rule. So you have to take peroxide along with HBr. And due to this peroxide, the reaction will be in different manner. That's why we are calling it as anti-Markovnikov rule. Anti-Markovnikov due to the reason because this will be in opposite sense of the Markovnikov rule. Markovnikov states that negative part of the reagent will be attached to the positive part. But in case of anti-Markovnikov rule, negative part will be connected with the negative carbon and positive part will be connected with the positive carbon, and this will be the major product in anti-Markovnikov rule. This will happen only with HBr in the presence of peroxide. If there is no peroxide, the reaction will take place according to Markovnikov rule. Let's understand with an example. Let's say I have CH3. If we have CH2 double bond CH2, this is again symmetric, so there is no problem in it whether you have peroxide or you do not have peroxide. Output will be same, and this will be CH3 CH2Br. But if the unsaturated hydrocarbon is like CH3 CH double bond CH2 and it is treated with HBr, no peroxide is there. So if there is no peroxide, reaction will be according to Markovnikov rule. This will be positive, this will be negative, and the major product will be CH3 CHBr CH3 along with a minor product which is CH3 CH2 CH2Br. This will be major and this is minor in this case. But if you are having peroxide, in the same reaction, CH3 CH double bond CH2 treated with HBr in the presence of peroxide, now the reaction will take place according to anti-Markovnikov rule, which implies that positive part will attack on positive part and negative on negative part. And in that sense, we will have CH3 CH2 CH2Br as major product and CH3 CHBr CH3 as minor product. So in anti-Markovnikov, this will be major and this will be minor. Is there any doubt? Any doubt?
No, sir.
Okay, should we move to the next reaction? Okay. Another important reaction is Grignard reagent is RMGX, which can also be given as RMG plus X minus, or we write it as RMGX. The important point about this reagent is it is the widely used reagent in organic chemistry, or this is the maximum possible used reagent. How it will react? Grignard reagent will show reaction only with those compounds which have active H. So the main target of Grignard reagent is to find out active H. Active H means active hydrogen. If we have a compound with active hydrogen and it is treated with RMGX, R of RMGX will take H or active hydrogen from that compound, will give alkane RX, and remaining part will be separated. Let's say this is X and the remaining part is Z. Let's say this is Z. So we just have to take care of active H. How will we decide whether a given H atom is active or not? So there are certain special cases in which hydrogen gets activated. Hydrogen with fluorine is active hydrogen. Hydrogen with oxygen is active hydrogen. Hydrogen with nitrogen is active hydrogen. And hydrogen with triple bond is also active hydrogen. So these are the active hydrogen. And if we have RMGX, we are going to have R bond H, because this alkyl group R will take H. Only H. Remaining part will be separated. Let's take an example. Let's say I have HOH treated with CH3MgBr. Since in H2H we have HOH and hydrogen is connected with O, which means this hydrogen is activated hydrogen or active hydrogen. So RMGX will show reaction with H2O, and we will have CH3 bond H, that is CH4 plus MgBrOH. Understood or any doubt? In some book we write it as MgOH Br. Another important reaction will be if we have RNH2 and it is treated with RMgBr or Cl or X. Again, hydrogen is present with nitrogen, which will have the activated hydrogen. So this will again give what? R bond H, and remaining part will be MgX and NH bond R. Are you getting it? Yes or no?
Yes, sir.
So RMGX can also give reaction with alcohol, because in alcohol again we have active H in the form of OH. So this will be ROH, and if you will treat it with RMGX, again this will give what? This will give RH plus MgX with OR. Understood? So this is the reason RMGX is very important. And another important point in RMGX Grignard reagent is that the alkyl group R may be of any form. It may be a straight carbon chain, it may be a branched carbon chain, it may be a carbon chain with large number of carbon atoms, or it may be a carbon chain with lowest possible number of carbon atoms. So it may be any type of carbon chain, long, short, straight, branch. Cyclic can also be, it can also be cyclic. Understood? Understood?
Yes, sir.
Okay. There are some important name reactions which are Finkelstein reaction. This reaction is especially used for the preparation of alkyl iodides. And in this reaction, we have RX, X may be Cl or Br, and it will be treated with NaI, sodium iodide or potassium iodide, Ki, in the presence of acetone, and it will give Ri plus NaX. Here, NaX form is reactive. If you will not use acetone, this reaction will go in reverse direction. But I want to have Ri, I want to have alkyl iodide. So I have to do something so that NaX is not able to react. And for that, we are doing the reaction in acetone. Acetone is organic solvent, and in organic solvent, NaX will be deactivated. NaX will be PPT, precipitated, and it will not react further. So we will have alkyl halide. So in Finkelstein reaction, acetone is very important. If acetone is not there, reaction will be reversible. Understood? Another important reaction is Schwarz reaction. Schwarz reaction. This is a reaction which is especially used to prepare alkyl fluoride. If we have Rx, X may be Cl or Br, and we are treated it with metal fluorides. Metal fluorides. Then we will have alkyl fluoride. We cannot prepare fluoride directly because reactions are explosive in nature and it will be difficult to break the bond. So metal fluorides are used. Which fluorides? There are certain special fluorides which are used. You can use silver fluoride, AgF, mercury fluoride, Hg2F2, cobalt, COF2, and antimony, SbF3. These are the fluorides which will be used. And this reaction is known as Schwarz reaction. Understood or any doubt? Yes. Okay. In maths, we have done the basic concept of limit, and I hope you have learned all the formulae of limit. Yes or no? Have you done the formulae?
Yes, sir.
Okay, let's start with the basic concept or basic formula. If we have limit extending to 0, sin x by x, what will be the answer?
1.
1.
Sir,
So if we have limit extending to 0, sin x by x or x by sin x, tan x by x or x by tan x, sin inverse x by x or x by sin inverse x, tan inverse x by x or x by tan inverse x. Answer will be 1. Yes or no?
yes, sir.
Yes, sir.
Limit extending to 0, sin of 5x divided by x. What will be the value? So in this case, argument of sin is 5x. Let me write it in this way. If you have, let's say, from the above formula, if we have limit f of x tending to 0, sin of f of x divided by f of x, answer will be what? Yes. What will be the answer? If we
Sir,
have
1.
1, if we have f of x tending to 0 and f of x is working as an argument of sin, so answer will be 1. So the question will be framed in such a way that there will be a function in argument of sin and that function will be tending to 0. So you have to manage that function in denominator also by manipulating it, and in that case answer will be 1. So let's say I have a question, a simple possible question. Limit extending to 0, sin of 5x upon x, what will be the answer?
Sir, 5.
According to the situation, it is sin of 5x. If x is tending to 0, 5x will also tend to 0. So limit extending to 0 indicates that 5x is tending to 0. So in denominator, according to the argument, it has to be 5x. So multiply and divide by 5. In that case, answer will be 5. Am I right?
Yes, sir.
Yes, sir.
Okay. Let's say I have limit extending to alpha sin of ax square plus bx plus c divided by ax square plus bx plus c, where alpha and beta are roots of ax square plus bx plus c. How will you solve it? Hello, hello, hello. How will you solve it? Hello, morning. जी तो 940 में ही ले रहा हूँ सर मैथ्स। हाँ हेलो ठीक है। So how will you solve it? Now if alpha is a root and beta is a root of the equation, you can by simple property of quadratic equation, you can write it as sine of a times x minus alpha into x minus beta divided by a times x minus alpha and x minus beta. Yes or no? Now if you will look at the if you will look at the arrangement of x tending to alpha, in that case x minus alpha will be tending to 0, and if x minus alpha is tending to 0, this will be 0 by 0 form. If you will look at here, this is 0 by 0 form, and in 0 by 0 form sin x by x give 1, or sine of f of x by f of x give 1. So sine of a x minus alpha x minus beta over a x minus alpha x minus beta. So this will be sine f of x by f of x, where f of x is tending to 0. So answer will be what? According to you, answer will be what? 1. Am I right? Yes or no?
Yes, sir.
If again I reframe it, let's say the question is limit extending to alpha, sine of x minus alpha x minus beta upon x minus beta. Then what will be the answer in this case? Since x is tending to alpha, so x minus alpha will be tending to 0. And in argument, we have x minus alpha and x minus beta. Sorry, there has to be, let me write here, x minus alpha. X minus alpha. So what will be the answer in this case? So this will be again 0 by 0 form. But this time, argument of sign and the function in denominator is not same. So you have to manage it. You have to arrange it. So this will be limit extending to alpha, sine of x minus alpha x minus beta divided by x minus alpha. To make the denominator expression same as argument of sign, I will multiply by x minus beta in numerator and denominator. And now if you will apply the concept of limit, this complete expression will be tending to 1, which implies we are left with limit extending to alpha x minus beta, and on substitution of limit, answer will be alpha minus beta. Understood?
Sir, solve one question on this formula.
On which?
On this formula, sir.
Which one? Alpha beta?
Yes, sir.
Okay. Let's say we have limit x tending to something, and there is x square minus 3x plus 2. Limit x tending to 2 divided by x minus 2, and I want to find out its limit. If you will put 2 into the expression, this will give you 0 by 0. This will give you 0 by 0. Am I right? So we will rearrange it. Limit extending to 2 sine x square minus 3x plus 2. What will be the factors? Factors will be x minus 2 and x minus 1. Am I right? X minus 2.
Yes, sir.
Now, if you will look at the argument of sign is different and expression in denominator is different. And that standard formula, limit f of x tending to 0 sine of f of x by f of x, will work if and only if we have argument of sign and denominator expression same. So I have to arrange the denominator expression to simplify it. And for that, what will I do? I will multiply and divide with the factor x minus 1. Now, if you will look at the concept, it will be limit extending to 2 sine of x minus 2 x minus 1 divided by x minus 2 x minus 1, and limit extending to 2 x minus 1 by the fundamental property of limit or algebra of limit, in which I have already told you that limit can be distributed. So I have distributed limit over two different functions. One is of sine and another one is simple linear function x minus 1. Now, this will be a complete property of sine of f of x divided by f of x. So this will be tending to 1. So this will be 1 into, and if you will put here limit 2 minus 1, this will be 1 into 1. So answer will be 1. Are you getting it?
Yes, sir.
Let's take one more another concept. If we have limit extending to 2, let me first write standard form. Standard form is, if we have limit x tending to a, x raised to power n minus a raised to power n divided by x minus a, what will be its answer? Yes, you have learned all the formulas. Tell me the answer. No one. एटलीस्ट किसी बच्चे को तो याद होगा. x raised to power n minus a raised to power n upon x minus a will be n into a raised to power n minus 1. And this is again 0 by 0 form. Questions will be like this. Let's say I have limit x tending to 2, x raised to power 2 minus 4 divided by x minus 2. What will be the answer? So you can convert it into limit x tending to 2 x square minus 2 square divided by x minus 2. 0 by 0 form, standard format. So answer will be 2 into 2 raised to power 2 minus 1, which means this will be 2 into 2, that is 4. Let's say I have limit x tending to 2 x square minus 8 divided by x minus 2. What will be the answer in this case? So you will write it as limit extending to 2 x square minus 2 cube, I think, but 2 cube will not work here, so it has to be 3. Power has to be same. Remember, power cannot be different. If here we have power n, here also power n, so power has to be same. So this will be x cube. This will be x cube minus 2 cube divided by x minus 2. And again, this will be according to standard formula. This will be 3 times 2 raised to power 3 minus 1. That is 3 into 2 raised to power 2, which will be how much? 12, I think. Yes or no?
Yes, sir.
Interesting point about this formula is that the power n has not to be natural number or a complete number. It may also be fractional. So the condition for n here is n belongs to any rational number. Let's say I have limit extending to root 2 and here we have x cube. Let me write it in fraction form. I want to have fraction. So let's say I have here limit extending to 3 and this is x raised to power 1 by 3 minus 27 divided by, or let me write here what I should write here what 3 divided by x minus 27 and limit is x tending to 27. Now if you will substitute 27 in numerator and denominator, you will get 0 by 0 form. So this question can be converted into a new format, x tending to 27, x raised to power 1 by 3 minus 3 can be written as 27 raised to power 1 by 3. Am I right? X minus 27. So in this case, power is in fraction, but question concept will be same and answer will be in this case 1 by 3 times 27 raised to power 1 by 3 minus 1. So it will be 1 by 3 times 27 raised to power 1 by 3 minus 1 will give us minus 2 by 3, which implies that 1 by 3 into this will be 27 raised to power 1 by 3 raised to power 2, and this will lead us to 27 raised to power 1 by 3 means cube root of 27, that will be 3, and 3 square will be 9. 9 into 3 will be 27. So answer will be 27. Understood? Understood or any doubt?
Understood, sir.
The same standard form can also be given in this way. Let's say we have limit extending to a, or let me write here limit f of x tending to a, and we have f of x raised to power n minus a raised to power n divided by f of x minus a. In that case also answer will be n into a raised to power n minus 1, which means question may also be framed in this way. Let's say, let me Let me arrange a question of this type. Limit x tending to 3 x plus 5 raised to power 2 minus let me write here let's say we have x plus 3 tending to 2 and it is x plus 3 to the power 2 minus to the power 2, or it may be 4 here, divided by according to condition x minus 1. What will be the answer? And if you look here, x plus 3 tending to 2 means x is tending to minus 1. So in place of x plus 3, we will have x tending to minus 1. Now the question is, limit x tending to minus 1, x plus 3 to the power 2 minus 4 by x minus 1. What will be the answer? What will be the answer? If we are having x plus 3 tending to 2 and in denominator, then it has to be plus 1. Now this will be a perfect question. So now if you will look here on substituting limit x equals to minus 1, this will be 0 by 0 form. And to deal with it, we have to convert it into standard form. And standard form will be limit extending to minus 1, which implies that x plus 3 will be tending to 2. So in place of limit extending to minus 1, I can rearrange it. Limit x plus 3 tending to 2, x plus 3 raised to power 2 minus 2 square upon, in place of x plus 1, I can write here x plus 3 minus 2. If you will take x plus 3 as z, so this question will look like limit z tending to 2, z square minus 2 square upon z minus 2. And this will be a standard form. So answer will be 2 into 2 raised to power 2 minus 1. This will be 2 into 2 raised to power 2 minus 1 means 2. Answer will be 4. So question may be framed in any different form. You just have to check what is the form, 0 by 0 or what is it. And you can then manage it. So how will we get the idea that this will be the form of x raised to power n minus a raised to power n? Remember, in such type of form, we have some variable values and along with variable we have some constant. So if there is a question in the form of variable and constant with certain powers, and obviously power is same, so first of all just look for the power in the question. Are the powers same? If the powers are same, then definitely this will be the standard format of the question, and then you can convert it. Understood or any doubt? Understood or any doubt?
Yes, sir. Understood.
Okay. Next, we have very important concept, which is known as L'Hopital's rule. This concept will work to find out the limit, to evaluate the limit, if and only if you have either 0 by 0 form or you have infinity by infinity form. How will it work? Let's say you have limit extending to a f of x divided by g of x, and when you substitute the limit, the format is going to be 0 by 0. If it is 0 by 0, L'Hopital rule states that you can differentiate in numerator and denominator separately and substitute the limit. So limit extending to a f of x by g of x will be same as limit extending to a f dash x divided by g dash x. Now in this case, there will be two formats. Either this will be a finite value on substitution of limit extending to a in f dash a by g dash a. If you will substitute a, this will be f dash a by g dash a. Either it will be a finite value. If it is a finite value, we do not have any problem. But if it is again 0 by 0 form, when you substitute a, it again turn to be 0 by 0 form. In that case, L'Hopital states that you can again differentiate it. So again differentiate it. Then again substitute the limit. Either it is going to be finite or it is going to be 0. If it is 0, again you can differentiate it. But if you are not getting any answer in 2 or 3 steps, then there is no benefit to carry on the process. Then you just have to go by some other technique or method. So L'Hopital rule will work if it is going to work in 2 or 3 steps. Are you getting it? So if you are having a question in 0 by 0 form, you can just direct solve it by L'Hopital rule. For example, I have the same question, which is limit extending to -1 x plus 3 to the whole square -4 divided by x plus 1. And we have to find out limit. First of all, I will check the format. If you will put -1 here, this will be -1 plus 3. 2 whole square will be 4 minus 4, 0. Divided by -1 plus 1 will be 0. So this is 0 by 0 form, which means you can directly solve it by L'Hopital rule. And for that, you have to differentiate it. Limit extending to -1. Differentiate in numerator separately and in denominator separately. So what will be the derivative of x plus 3 raised to power 2? Derivative will be 2 into x plus 3. And derivative of -4 will be 0. Divided by derivative of x plus 1 will be 1. And if you will put the value, this will be 2 into -1 plus 3. That is 2 into 2. Answer will again be 4. This is known as L'Hopital rule. You can apply this rule in any question if the question is in the format of 0 by 0 form or infinity by infinity form. Are you getting it or any doubt? Okay. Let's take one more standard format. Limit extending to infinity. Some expression divided by some expression. And the format is definitely infinity by infinity. I want to delete. So first approach may be L'Hopital rule. Another one is if this question is in the format of polynomials, then we can have a different approach. Let's say the question goes like this. Limit extending to infinity x raised to power n an plus an minus 1 x raised to power n minus 1 and so on. Same we have in denominator bn x raised to power n plus bn minus 1 x raised to power n minus 1 and so on. If you will substitute the limit, it will be infinity by infinity form. To deal with such type of question, we state that it is x, not n. We state that take the maximum power common from numerator and denominator. So from numerator, maximum power is x raised to n, and you are left with an plus an minus 1 upon x plus an minus 2 upon x square plus dash dash dash, because maximum possible power is outside. Similarly, in denominator, this will be bn plus bn minus 1 over x, and the story goes on. Now, interesting point is that the common factor will cancel out, and when you will substitute limit, now these factors will be tending to 0, because in numerator we have something finite and in denominator we have tending to infinity. So finite value divided by tending to infinity will be tending to 0, which means answer will be an divided by bn. So the trick goes like, if we have polynomial function in the limit and the format is infinity by infinity, answer will be ratio of the coefficient of maximum power, which means if I write here limit extending to infinity 2x cube plus 4x square minus 3x plus 5 divided by 5x cube minus 2x square plus 6x plus 6. By substitution of limit, it is obviously infinity by infinity. You can solve it either by L'Hopital rule or you can solve it by the concept. And the concept is take maximum power common. If you will take maximum power common, you will be left with coefficient of the maximum power. Remaining other part of the expression will be 0. So I'm not going in detail. I will just write the answer. In this case, answer will be ratio of the coefficient of maximum power of the variable x. That is, answer will be 2 by 5. Are you getting it or any doubt? Okay. What will happen if the power is not same in numerator and denominator? Let's say I have limit extending to infinity and it goes like 2x cube plus 3x square plus 5x plus 4 and divided by x square plus x plus 1. What will be the answer? In this case, maximum power in denominator is x square, so we can take x square common. This will be limit extending to infinity, take x square common. This will be 2x plus 3 plus 5 by x plus 4 by x square divided by x square. This will be 1 plus 1 by x plus 1 by x square. And on the substitution of limit, you can clearly state that this is going to be 0, this is going to be 0, going to be 0, going to be 0. This will cancel out. So we will left with 2x plus 3 divided by 1. If x is tending to infinity, obviously 2x will tend to infinity and 2x plus 3 tends to infinity. So this will be by 1, infinity by 1 will be infinity. Which means if power in numerator is greater than power in denominator, answer will always be tending to infinity. And if power in denominator is greater than power in numerator, answer is always going to be tending to 0. And if the power is equal, in that case, answer will be ratio of the coefficient of maximum power. Are you getting it or any doubt?
So, sir, without solving, we can directly solve it.
Yes, you can directly tell it. if it is in polynomial form, this concept is valid for polynomial form. If the question is not in polynomial form, it is in some different arrangement of functions, not polynomial function. In that case, either you have to select another technique, special technique, or you just can go by L'Hopital rule. There are lots of different concepts for different format. Understood?
Yes, sir.
Okay, remaining we will do in next session. Next session I think Monday में होगा ना अब?
Yes, sir.
Yes, sir.
Okay. Do you have any doubt? ये लेक्चर कौन लेगा अभी 9:40 वाला? चलेगा, मैं होस्ट बना देता. ये अनीस डिफेंस वाला ही है ना? ये इसमें एक ज्वाइन किए हुए हैं अनीस डिफेंस कैरियर इंस्टीट्यूट, इन्हीं बनाना ना? या अभी ज्वाइन करोगे आप? आप करोगे अभी ज्वाइन? Okay, tell me what will be the limit extending to 0, greatest integer x.
X.
Limit extending to 0, greatest integer x.
X.
X, how?
Standard result.
वाओ, किसने बताया आपको ये स्टैंडर्ड रिजल्ट? ये बताओ पहले.
0.1.
0.1. Greatest integer is something like this. Am I right? Look at the behavior of the graph. If you will look at 0 plus 0 plus, it will be 0. If you look at 0 minus, it will be -1. So limit extending to 0 plus greatest integer is 0, and limit extending to 0 minus greatest integer is -1, which implies that left hand limit is not equals to right hand limit. And if it is the case, does the limit exist? Yes, tell me. If left hand limit is not equals to right hand limit, does the limit
Sir,
exist?
screen is not visible.
Yes.
Sir, your screen is not visible.
मैंने होस्ट चेंज कर दिया भाई, इसलिए हुआ ऐसा। अभी तो आप ये बताओ लिमिट एग्जिस्ट करता कि नहीं करता? Left hand limit
No, sir,
is not
doesn't.
equals to right hand limit. So remember,
नहीं करता.
remember, if it is greatest integer function, it will not give you limit at integral points, whether it is 0 or 1 or 2 or -1 or any another integer. So limit x tending to any integer, greatest integer x, answer will be limit does not exist. If the question is what is the left hand limit of greatest integer x at extending to 0? So left hand limit means limit extending to 0 minus greatest integer, then it will be -1. If it is left hand limit, right hand limit, we can justify. But if it is limit, answer will be limit does not exist at integral points. Understood?
Yes, sir.
Okay.
Okay, I think we shall continue. Okay, so just a minute, I will be taking one call from the academy, then we'll continue. Okay, so I think my screen is visible and I will be talking to you for a minute or two. Firstly, you should understand one thing is that all of you are preparing for IMU CET, right?
Yes, sir.
I can see here almost 25 students, Arushi, and Ahmed, Akshit, Ame, Anmol, Muhammad, Prakash, Pranav, Ritik, Roli. Okay, so all of you, and I think you might be knowing about the structure of the exam, particularly. You know how many questions are coming from the English section?
Sir, 40.
Okay. Now, I will be telling you the focus areas first. Okay, because I think by 25th or 24th, we will be completing our English syllabus. Okay, so just pay kind attention. Let us say what we have to focus on, because recently we have seen many exams related to IMCT for sponsorship also. You might be knowing about. Have you given, anyone had given these Tolanis and others papers for sponsorship apart from IMCT or appeared? Because I need to see, do you have any experience of that?
Sir, I have.
You have this year's Tolani, Synergy, Rahman, Noida. Have you appeared? All of you, just unmute yourself. We will be talking. Then we will continue
Yes,
for the
sir.
lecture. Okay, yeah, given. So those who have appeared, they know what kind of questions are coming. The level of the question is only moderate. Tough questions from the English sections are not expected. Okay, so the English section will be much easy, and I will be dictating few points that we need to cover. Firstly, what you need to do is that you need to focus on certain areas. Like one of the area is, for example, tenses. Second, change the voice. Third, degrees. Fourth, narration. Okay, that is direct, indirect, direct speech, and indirect. Fifth, you have spelling errors. Sixth, you have synonyms. Seventh, antonyms. Eighth, one word substitution. Ninth, idioms, phrases. 10th, you have sentence completion. 11th, we also be studying about the sentence rearrangement. 12th, comprehension. You can take the screenshot. Okay, this much part we are going to cover. Okay, so I will also be sharing the material in the PDF forms. I will be sharing it in PDF form. PDF notes will be provided to you of all the lectures. So even if you are, and apart from that, reference material will also be provided. So, and apart from that, mock test. So you need to refer to all of this: PDF notes, reference materials, and the mock test. I need to you need to pay kind attention. I need to engage with me. You need to ask me questions. It should be one-to-one interactive session. Okay, आपको जब भी ऐसा लगता है कि सर ये चीज समझ में नहीं आई, क्योंकि देखो मैं आपको एक बात बताता हूँ, आईएमयू सीईटी में डेप्थ नहीं है। आईएमयू सीईटी के अंदर मॉडरेट लेवल का पेपर होता है। अभी तक का एक्सपीरियंस ये है कि मॉडरेट लेवल का पेपर रहेगा, है ना। एक्सपेक्टेड ही नहीं है कि बहुत हाई क्वालिटी के क्वेश्चंस इंग्लिश के अंदर पर्टिकुलरली जैसे एनडीए में आता है, या फिर उस लेवल के जो क्वेश्चन रहते हैं जितनी डेप्थ रहती है, जैसे कि स्पॉट द एरर क्वेश्चन। मैंने स्पॉट द एरर का नाम लिखा नहीं क्योंकि स्पॉट द एरर की बहुत ज्यादा क्वेश्चंस एक्सपेक्टेड नहीं है, फिर भी हम लोग स्पॉट द एरर का सेक्शन पढ़ेंगे क्योंकि हम लोग हर एरिया का रूल पढ़ेंगे। जब रूल पढ़ेंगे तो उसी रूल के अंदर चेंजेस करके वो क्वेश्चंस बनाते हैं। फॉर एग्जांपल जैसे टेंसेस में, तो टेंस के अंदर कुछ मिस्टेक कर देंगे और उस पे से स्पॉट द एरर का क्वेश्चन बन जाता है, तो हम लोग वो भी देखेंगे। ओके, तो आई थिंक ऑल ऑफ यू आर अवेयर नाउ अबाउट दिस सिलेबस। इसमें बहुत इंटरेस्टिंग फैक्ट स्पेलिंग एरर की है ना। स्पेलिंग एरर में क्या होता है, हम लोग बहुत उसको कैजुअली लेते हैं स्पेलिंग एरर को, और मैंने पिछले 4-5 साल में ये देखा है कि बच्चे बहुत ज्यादा मिस्टेक स्पेलिंग एरर में करते हैं। सिनोनिम एंटोनिम तो करते रहते हैं हम लोग, क्योंकि सब लोग को मालूम रहता है कि इसमें से क्वेश्चन आते हैं, तो कर देते हैं। चेंज द वॉइस में गड़बड़ कर देते हैं। जैसा मैंने आपको अगर एक बात बोला तो तुम में से कितने लोग चेंज द वॉइस कर पाएंगे? मैंने बोला फॉर एग्जाम्पल वर्क हार्ड, वर्क हार्ड, ये 2 वर्ड का एक सेंटेंस है, वर्क हार्ड फुल स्टॉप। तुम में से हाथ ऊपर करके बता सकता है कोई कि इसका पैसिव वॉइस क्या हो जाएगा? अब ये क्वेश्चन मैंने आईएमयू सिटी में डाल दिया, वर्क हार्ड, बताओ प्रकाश।
So can you repeat the question?
वर्क हार्ड का पैसिव वॉइस में चेंज करना है। वर्क हार्ड, ये मैंने दिस इज, मैं एग्जांपल दे रहा हूँ, जस्ट गिविंग वन एग्जांपल टू यू। ओके, हमको इंग्लिश आती है बट स्पीकिंग इंग्लिश बहुत डिफरेंट होती है, और जो ग्रामर वाली इंग्लिश होती है ना वो बहुत डिफरेंट होती है। जो कॉन्वेंट से बच्चे पढ़े हैं, फॉर देम इंटरव्यू आपके लिए केक वॉक होगा, बहुत अच्छे से आपका सब कुछ हो जाएगा। लेकिन जब ग्रामर वाले इंग्लिश में कोई बात आएगी तो बहुत सिली मिस्टेक करेंगे। ऐसा नहीं कि यू डोंट नो, मैं ये नहीं बोल रहा हूँ कि आपको आता नहीं है, आपको आता है, बट ड्यू टू लैक ऑफ रिविजन, और बहुत साल हो गए, आप 10th में पढ़ा था आपने कभी, उसके बाद 11th 12th हुआ और आप मतलब उसमें ध्यान ही नहीं दिए, तो इसकी वजह से आपका ग्रामर सेक्शन वीक रहता है। स्पेलिंग में भी यही इशू है कि हम लोग व्हाट्सएप वाली लैंग्वेज यूज करते हैं, स्लैंग यूज करने की आदत हो गई हमको, तो हम लोग वो फॉर्मल इंग्लिश की बात ही नहीं करते हैं, है ना। जैसे कि अगर किसी को बोला कि एक क्वेश्चन बनाओ इंग्लिश के अंदर, तो उनको डू डिड या डज से प्रॉपर एक क्वेश्चन बनाने नहीं आता है, तो ये इशू है हमारे साथ। ओके, so without wasting much time, let us start to point number 1, tense. Now as you can see here, we have a couple of books, you can see couple of books out here, we will be referring to that, and we have notes, like for example these are for spelling mistake note. We can see lot of questions are given, you need to practice. We will be practicing such questions which are coming, which have occurred in various एग्जाम्स, लाइक एसएससी सीजीएल में जितने क्वेश्चन आए सबको ये किया है, यहाँ पर दिख रहा है आपको। तो ये पूरे क्वेश्चन जब आप करते हो, इससे बाहर आता ही नहीं क्वेश्चन, दिख रहा है। ऐसे नोट्स है अपने पास रेडी, वो नोट से ही हम लोग पढ़ते हैं। जैसा ये स्पेलिंग एरर के क्वेश्चन है, दिख रहा है आपको स्पेलिंग एरर, देख जब आप ये प्रैक्टिस करोगे बार बार बार, तो आपके क्वेश्चंस गलत नहीं होंगे। ओके, ये वोकैबुलरी के बुक्स है, ये कॉमन एरर का बुक है, कॉमन एरर्स किस में क्या गलती होती है, मैं आपको बस रूल्स बता रहा हूँ पहले कि गलती। इडियम्स एंड फ्रेजेस का है, इडियम्स एंड फ्रेजेस के भी नोट्स है, ठीक है। और ये ग्रामर के पूरे नोट्स है, डिटेल के अंदर आपको इस टाइप के नोट्स मिल जाएंगे, ठीक है। ये सब मटेरियल आपको मिलने वाला है, राइट। So don't worry about the material, you will be getting all the material. चलो हम लोग स्टार्ट करते हैं टेंस से। सबसे पहले तो हम आते हैं सिंपल प्रेजेंट टेंस। सिंपल प्रेजेंट टेंस में इंपॉर्टेंट चीज क्या है, देखो सबसे पहले आपको उसका फॉर्म पता होना चाहिए कि आप यूज कैसे करने, और उसका मतलब फॉर्मूला, सिंपल प्रेजेंट टेंस को आप यूज कैसे करेंगे, ठीक है। सिंपल प्रेजेंट टेंस, सिंपल प्रेजेंट टेंस में इंपॉर्टेंट क्या होता है, सब्जेक्ट प्लस V1 प्लस ऑब्जेक्ट। इतना सिंपल सी चीज है, ये इसका फॉर्मूला है। ये एक बार आ गया तो सिंपल प्रेजेंट टेंस में कुछ भी गलती होने के चांसेस कम रहते हैं। जैसे आप यहाँ देखते हो, आपके पास सब्जेक्ट प्लस वर्ब प्लस ऑब्जेक्ट का मैं सेंटेंस बताता हूँ। सब्जेक्ट प्लस V1, सब्जेक्ट है ही, works hard. I go to school. They play cricket. आप देख रहे हो सिंपल सा फॉर्मूले में ये फिट बैठ रहा है ना। तुम में से कोई एक सेंटेंस बना सकता? चलो एक एक सेंटेंस बनाओ, कोई अनम्यूट करो जिसको एक सेंटेंस बना सकता है, फिर हम लोग आगे बढ़ेंगे और देखेंगे कि क्या क्या गलतियां हो सकती है। एक सेंटेंस बना के बताओ। चलो बोलो एक 3-4 सेंटेंस।
मदर कुक फूड.
मदर कुक्स फूड. ओके, फिर देखेंगे
She
कहाँ
runs,
आर्टिकल में। यस,
she runs fast.
ओके ही। ये देखो कुछ कुछ लोगों को समझ में आ रहेगा, यहाँ पे एस लग रहा है।
Sir, I do exercise every day.
आई डू एक्सरसाइज। अरे देखो ये वर्ड आ गया एवरीडे। ये जो एवरीडे ऐसा वर्ड है ना, हाँ एक मिनट मैं एक्सप्लेन करता हूँ। एवरीडे जो ऐसा वर्ड है, ऐसे वर्ड्स जनरल जो आते हैं सिंपल प्रेजेंट टेंस में आते हैं, तो ये भी ट्रिक्स रहते हैं। पढ़ जैसे एस लग गया मतलब तो क्या है, ये पक्का सिंपल प्रेजेंट टेंस का है। दूसरी तरफ प्रेजेंट टेंस में एस लगता ही नहीं। ओके, अभी यहाँ देखो आई के साथ गो आ रहा है और ही के साथ गो जाएगा, तो अब एक एक रूल जिसका इंग्लिश का अच्छा है उसके लिए मैं बता रहा हूँ। सब रूल बेसिस से स्टार्ट कर रहे हैं हम लोग इसीलिए, वरना तो जिनका इंग्लिश अच्छा है उनको लिए बहुत केक वॉक है। नॉट दैट टफ फॉर यू। यस, कोई कुछ बोल रहा था? यस प्लीज कंटिन्यू, किसी को कुछ बोलना था? यस, सिंपल प्रेजेंट टेंस में एक रूल इसमें लिख के लो या फिर मैं शेयर कर दूंगा तो आप इसको रखना। ये रूल नंबर 1, ये अपना एस का रूल है कि एस कब यूज करते हैं, जब और एस इस और एक वर्ड आता है ई एस फॉर एग्जाम्पल, इसको सफिक्स बोलते हैं। प्रीफिक्स और सफिक्स, प्रीफिक्स मतलब जब सामने लगेगा, सफिक्स मतलब जब पीछे से उसका यूज होगा। ओके, जब ई एस हम लोग एज अ सफिक्स यूज करते हैं, कब यूज करते हैं? जब सेंटेंस में ओ या फिर एस एच, सी एच, एस एच या डबल एस, एक्स, जेड, अगर ऐसे लेटर से एंड होता है वर्ड, जैसा कि गो है तो एंड हो रहा है ओ से, तो ये बनेगा गोज ना कि गो। ओके, जैसा एक वर्ड है वॉच, जो सी एच से एंड हो रहा है तो बनेगा वॉचेस ना कि वॉच। ठीक है, वैसे एक वर्ड आपको दिखता है फिनिश, जो एंड हो रहा है एस एच से, इसका बनेगा फिनिशेस। आपने और रवि शास्त्री की कमेंट्री सुनी होगी जब 2011 का वर्ल्ड कप इंडिया जीता था ओडीआई का, धोनी फिनिशेस ऑफ इन स्टाइल। सुना है वर्ड कमेंट्री?
यस सर.
जब हाँ तो क्या वर्ड आया था? फिनिशेस ऑफ इन स्टाइल। ठीक है, तो ये बेसिक बेसिक है। अच्छा ये गलती अपने को एग्जाम, अभी तो सब इजी लगता है, जब एग्जाम में ये वर्ड्स आते हैं ना हमारा दिमाग ही काम नहीं करता। हम लोग बहुत इजीली लेते हैं ना हर चीज को, इसीलिए। तो सिंगुलर सब्जेक्ट के साथ एस लगता है। रूल क्या है यहाँ, ये लिखूंगा मैं कि सिंगुलर सब्जेक्ट के साथ, मैं यहाँ एक रूल बनाता हूँ कि सिंगुलर सब्जेक्ट्स सिंगुलर सब्जेक्ट के साथ जैसे कि ही, शी, इट, इसके साथ यस या ईएस आता है, और प्लूरल सब्जेक्ट्स, ओके, प्लूरल सब्जेक्ट के साथ एस नहीं आता, मतलब वी का सिर्फ वन फॉर्म रहेगा, यस यूज नहीं करेंगे, ठीक है। जैसे कि दे के साथ आप वी का फॉर्म यूज करेंगे विदाउट विदाउट एस, ओके। ये इसी इतना जो आपने सिंपल प्रेजेंट टेंस पढ़ा है, इतने में किसको कुछ प्रॉब्लम है तो बताओ, फिर आगे हम लोग ऐड करते जाएंगे। इतने जो
नो सर।
यस कब
नो
यूज
प्रॉब्लम।
करना है कब यूज नहीं
No,
करना,
sir.
ओके चलो। अब आते हैं हम थोड़ा अलग फॉर्मेट में। अभी हमने अफर्मेटिव सेंटेंस देखा, मतलब पॉजिटिव सेंटेंसेस देखा। अब आते हैं हम नेगेटिव सेंटेंसेस में। आपको सिर्फ इतना देखना है कि नेगेटिव सेंटेंसेस बनते कैसे, ओके। नेगेटिव सेंटेंसेस कैसे बनते हैं, फिर आगे हम देखेंगे इंटरोगेटिव सेंटेंसेस कैसे बनते हैं, ठीक है। अब आते हैं हम लोग नेगेटिव सेंटेंस पे। नेगेटिव सेंटेंसेस का फॉर्मेशन कैसे होता है, सेंटेंसेस आपको दिख रहा है यहाँ पे, क्योंकि ये सब है ना, देखो टेंस क्यों ले रहे हैं हम लोग स्टार्टिंग में, क्योंकि टेंस लेंगे ना तो सब चीजें इस पे डिपेंड है। फॉर एग्जाम्पल इसके बाद का चैप्टर है चेंज द वॉइस। चेंज द वॉइस जिसको टेंस नहीं आता उसको आ ही नहीं सकता, आ ही नहीं सकता जिसको, मतलब कुछ ना कुछ गड़बड़ी करेगा। और ऑप्शंस ऐसे फ्रेम होते हैं ना, आपको चारों के चारों सही लगेंगे। देखो, आई वर्क, आई डू नॉट वर्क। अब जिसकी इंग्लिश कमजोर है ना उसको लगता है सर ये आई वर्क तो समझ में आ रहा है, लेकिन मैं आई नॉट वर्क क्यों नहीं बोलूं। समझ में आ रहा है, जिनकी इंग्लिश थोड़ी वीक रहती है, जिसकी प्रैक्टिस नहीं रहती, वो ऐसा बोलेगा सर आई नॉट वर्क क्यों नहीं, आई वर्क तो सही लग रहा है, फिर आई नॉट वर्क क्यों नहीं। तो इसीलिए आपको डू और डज का, डू डज डिड ये समझ में आना चाहिए। ये पता होना चाहिए कि डज कब यूज करते हैं, डू कब यूज करते हैं, डिड कब यूज करते हैं, क्योंकि अपने को ये यूज करना है। जैसे यहाँ लिखा ही वर्क्स तो आया ही डज, है ना। आई गो, आई डू नॉट गो, ही गोज, ही डज नॉट गो। अब जो सेंटेंसेस आपने दिए थे मुझे, ये वाले, राइट। अभी जिसने दी इस सेंटेंस को, इसी सेंटेंसेस को हम क्या करेंगे, नेगेटिव में कन्वर्ट करेंगे समझ में आने के लिए। अब आपने एक सेंटेंस दिया ही वर्क्स हार्ड, कोई बता सकता है इसका नेगेटिव सेंटेंस कैसा बनेगा।
He does not
He
work
does not
hard.
work hard.
राइट,
He
ही
does not work, sir.
डज, वर्क्स नहीं आएगा। देखो अभी एक गलती होगी, किसी ने कर दिया, किसी ने बोला ही डज नॉट वर्क्स हार्ड, सही है कि है?
नहीं सर।
क्योंकि यस ऑलरेडी लगा दिया ना हमने यहाँ पर, यहाँ पे यस लग गया, तो इसकी जरूरत है क्या, नहीं है। तो ही डज नॉट वर्क हार्ड, इसका बोलो। नेक्स्ट,
I do
I do
not
not
go
go
to
to
school.
school.
आई
Go to school.
डू नॉट गो, सिंपल है। दे
Do not play cricket.
प्ले,
Don't play.
हाँ सिंपल, यही बस एक गलती थी। अच्छा ऐसे ही गलती है ना सिंपल प्रेजेंट टेंस में करते, सॉरी सिंपल पास्ट टेंस में करते लोग। जैसे है ना, डिड यूज करके एक सेंटेंस बना दो, कोई डिड यूज करो और इससे एक सेंटेंस यूज करो, सेंटेंस बनाओ कोई।
I did not go to school.
Did you go there?
हाँ दोनों भी सही है, आई डिड नॉट गो टू स्कूल। अच्छा इसमें क्या करते हैं बच्चे, आई डिड नॉट वेंट लिख देते हैं, आई डिड नॉट वेंट टू स्कूल। उनको लगता है कि हम लोग अब पास्ट टेंस में बात कर रहे हैं, तो पास्ट टेंस में तो वेंट आना चाहिए, इसीलिए उनको क्या लगता है आई डिड नॉट वेंट टू स्कूल, मैं स्कूल गया ही नहीं था, ऐसा उनको बोलने का रहता। लेकिन उनको ये पता नहीं होता है कि डिड ये फंक्शन यूज कर रहे हैं ना हम लोग, जब डिड ऑलरेडी यूज कर रहे हैं तो यहाँ पे वेंट लगाने की जरूरत ही नहीं है। तो यहाँ पे हम सिंपल सिंपल गो लगाएंगे V1 का फर्स्ट फॉर्म, क्योंकि ऑलरेडी यहाँ पे डिड आ गया, वैसा ही जब लास्ट में डज आता है तो वर्क्स बोलने की कोई जरूरत नहीं है। तो ये बेसिक रूल्स है। एक बार ये इस टाइप के आपका सेंटेंसेस कंप्लीट हो गए तो आपकी इंग्लिश, ये देखो बेसिक है, सुनने में बहुत बेसिक लगता है, लेकिन आईवीसीटी इसी को ट्विस्ट करके क्वेश्चंस बनाती है। दिख रहा है? फिर यहाँ पे देख लिया हमने। अब हम आते हैं प्रेजेंट कंटिन्यूअस टेंस पे या प्रेजेंट प्रोग्रेसिव टेंस पे। ठीक है, प्रेजेंट कंटिन्यूअस टेंस बोलो या फिर प्रेजेंट प्रोग्रेसिव टेंस। तो मैं नाम लिखता हूँ, उसका स्ट्रक्चर देखेंगे। अच्छा, अफर्मेटिव सेंटेंसेस रह गए, सॉरी यहाँ पे एक चीज रह गई, अफर्मेटिव। ये भी इंटरेस्टिंग है। अभी इंडिया में स्टाइल कैसी है क्वेश्चन बनाने की, पता है? मतलब मैं स्लैंग में बोल रहा हूँ, हम लोग हर क्वेश्चन के पीछे ना लगा देते हैं। हाँ, मतलब ये ना लगा के क्वेश्चन बनाने की आदत है हमको। ऐसा कुछ ना लगा क्वेश्चन नहीं बनते कभी। पूरा फॉर्मेट सिंटैक्स चेंज करना पड़ता है क्वेश्चन का। ओके, तो याद रखो, सबसे पहले तो इंटरोगेटिव में कैसे समझ में आएगा कि इंटरोगेटिव सेंटेंस है, तो क्वेश्चन मार्क से, और अरेंजमेंट ऑफ द वर्ड्स से। यहाँ देखो, आई डू नॉट वर्क, क्वेश्चन पूछा है डू आई वर्क, डज ही वर्क, डू आई गो। मतलब सब्जेक्ट के पहले डू और डज आ रहा है, दिख रहा है? सब्जेक्ट बाद में आ रहा है। देखो जितने सेंटेंसेस है, ये भी इन्फिनिटिव्स हो या फिर सॉरी इज आर हो, डिड हो, ये कहाँ आ रहे हैं? ये सब आ रहे हैं सब्जेक्ट के पहले। डू आई वर्क, डज ही वर्क, डू आई गो, डज ही गो। तो इसका फॉर्मेशन बहुत इंपॉर्टेंट है, क्योंकि ये इंटरोगेटिव क्वेश्चन का जब चेंज द वॉइस करते हैं ना, तो बहुत परेशानी होती है ना? किसी को आता नहीं इंटरोगेटिव इंटरोगेटिव सेंटेंसेस का चेंज द वॉइस करना। तो वी आर कमिंग बैक टू दी प्रेजेंट कंटिन्यूअस टेंस। इसको प्रेजेंट प्रोग्रेसिव टेंस भी बोलते हैं, लेकिन मैं प्रेजेंट कंटिन्यूअस टेंस ही बोलूंगा। ब्रिटेन में वगैरह प्रेजेंट कंटिन्यूअस टेंस को प्रेजेंट प्रोग्रेसिव टेंस बोलते हैं। तो इसका फॉर्मूला क्या है? ब्रैकेट में मुझे क्या लिखना पड़ेगा? सब्जेक्ट, मराठी में जिसको कर्ता बोलते हैं हम लोग, हम इज आर प्लस वर्ब आईएनजी। वर्ब आईएनजी मतलब वर्ब को आईएनजी लगाएंगे कंटिन्यूअस टेंस में, और लास्ट में आएगा ऑब्जेक्ट। ओके, तो ये हमारा क्या हो गया? फॉर्मूला। इसी फॉर्मूले से हम चलने वाले, जितने वर्ड्स बनेंगे हमारे इसी फॉर्मूले के रहेंगे। ठीक है, देखो एग्जांपल बताता हूँ मैं। शी इज, देखो मैं आपको समझ में आने के लिए, शी इज गोइंग टू स्कूल। फॉर्मूले में फिट करते हैं सब्जेक्ट, हम इज आर, वी आईएनजी, और ये ऑब्जेक्ट। समझ में आया? तो जितने सेंटेंसेस है उसको अब हम क्या करते हैं? कन्वर्ट करते हैं सेंटेंसेस को। सिंपल प्रेजेंट टेंस को कन्वर्ट करते हैं हम लोग सिंपल प्रेजेंट टेंस को कन्वर्ट करते हैं प्रेजेंट कंटिन्यूअस में। फॉर एग्जांपल मैंने दिया दे प्ले क्रिकेट, कन्वर्ट करो इसको प्रेजेंट कंटिन्यूअस में, प्रेजेंट कंटिन्यूअस में कन्वर्ट करो।
They
They
are
are
playing
playing cricket.
cricket.
राइट, दे आर, ये आर यहाँ का, और ये आईएनजी, प्लेइंग क्रिकेट। ठीक है, तो इस टाइप का कन्वर्जन हमको आना चाहिए। बाद में बोल देते हैं कन्वर्ट दिस सेंटेंस इनटू प्रेजेंट कंटिन्यूअस, पास्ट कंटिन्यूअस, पास्ट परफेक्ट, प्रेजेंट परफेक्ट, फ्यूचर परफेक्ट। फ्यूचर परफेक्ट कंटिन्यूअस। अभी धीरे धीरे तो टेंसेस जैसा जैसा आगे पड़ेगा वैसा वैसा टफनेस उसका बढ़ते जाएगा। हम देख अब कैसे लिख सकता हूँ मैं, वी आर वॉचिंग अ मूवी। इसको अब तुम कन्वर्ट करो, सिंपल प्रेजेंट में करो कन्वर्ट।
वी
तुम में से
वॉच मूवी।
ही, अच्छा वी वॉच
वॉच अ मूवी।
अ मूवी, वी वॉच अ मूवी, इसका कन्वर्जन किया तो वी आर वॉचिंग अ मूवी। अच्छा ये देख, एक चीज यहाँ पे और मिस हो गई मेरे को जो लिखना है, 13 पॉइंट, ये भी ऐड कर लो, आर्टिकल्स और पार्ट ऑफ स्पीच। ठीक है, ये भी हमको करना पड़े। और इसके अंदर, इसी के अंदर है ना, प्रीपोजिशन वाला सेक्शन बहुत इंपॉर्टेंट है सेंटेंस कंप्लीशन में। इसका स्क्रीनशॉट ले लो आप, क्योंकि इतना पढ़ना है हमको।
सर ये पीडीएफ आप ड्राइव में अपलोड नहीं कर सकते क्या?
कर दूंगा, मैं कर दूंगा,
अच्छा।
कर दूंगा, कोई बात नहीं। लेकिन कैसे कुछ कुछ चीजें स्क्रीनशॉट में रहती है मोबाइल में, तो उसकी बात कुछ अलग रहती है, रेडी टू यूज रहता है, चलते फिरते देख सकते हैं कि हाँ इतना कवर करना है अपने को। ठीक है, ये सब हम देख रहे थे प्रेजेंट कंटिन्यूअस का। देखो अ, जैसा जैसा मैंने प्रेजेंट टेंस में बोला था कि एवरीडे ये वर्ड यूज होता है, और किसी ने बनाया था एवरीडे से सेंटेंस भी बनाया था। देखो यहाँ पे ये एवरीडे वाला सेंटेंस था, वैसा ही सेंटेंस यहाँ पे यूज होता है, नाउ, एट द मोमेंट, लुक, लिसन। ये ऐसे वर्ड यूज होते हैं प्रेजेंट टेंस में। आई एम वर्किंग नाउ, आ गया नाउ, ऐसे। तो इस टाइप के, इस पे से भी समझ में आता है कि प्रेजेंट कंटिन्यूअस टेंस कब यूज करते हैं। तो प्रेजेंट कंटिन्यूअस टेंस तब यूज किया जाता है जब हम बात कर रहे हैं, उस वक्त वह एक्टिविटी हो रही है। लाइक आई एम टीचिंग, अब मैं जब पढ़ा रहा हूँ और जब मैं बात कर रहा हूँ, इसीलिए मैंने क्या बोला, आई एम टीचिंग, क्योंकि अभी मैं जब आपसे बात कर रहा हूँ तो मैं पढ़ा रहा हूँ आपको। यू आर लर्निंग, अब जब आप मेरी बातें सुन रहे हैं तो आप, यू आर लिसनिंग टू मी इस एट दिस मोमेंट। ओके, इसीलिए जब आपने को प्रेजेंट हैपनिंग चीज जो अभी इस वक्त हो रही है वो बताना होता है, तो अब हम लोग यूज करते हैं प्रेजेंट कंटिन्यूअस टेंस। जैसे कि आई एम वर्किंग, ही इज वर्किंग, आई एम गोइंग, इज गोइंग, आई एम। अच्छा निगेटिव में क्या करेंगे, सिंपल सिंपल नॉट लगाएंगे यहाँ पे। यहाँ पे सिंपल प्रेजेंट जैसा कुछ इशू नहीं है कि डू यूज करो, डज यूज करो, सिंपल नहीं। आप यहाँ पे स्ट्रेट फॉरवर्ड नॉट यूज कर सकते, क्योंकि उसके सपोर्ट में यहाँ पे बी के, टू बी के फॉर्म है। टू बी का फॉर्म क्या रहता, हम, इज, आर, ये टू बी के फॉर्म है प्रेजेंट टेंस में। ओके, और वाज वेयर उधर पास्ट में, विल फ्यूचर में। ये देखो, हम नॉट, इजंट, इजंट, ओके। और उल्टा यहाँ पे कैसा आएगा, हम आए वर्किंग। अच्छा निगेटिव सेंटेंस बना सकता है इसका कोई, हम आए वर्किंग विदाउट चेंजिंग द मीनिंग, कोई बता सकता है? देखो, देखेंगे किसी को आता क्या। इसी सेंटेंस को, जैसे इसको हमने बनाया नेगेटिव, हम वर्किंग को बनाया हम नॉट वर्किंग, सो हम आई वर्किंग को नेगेटिव बनाओ, बना सकते हैं नेगेटिव विदाउट चेंजिंग द मीनिंग। ये जब बनाना सीख जाते हैं तब ये बोल सकते हैं कि हमारे इंग्लिश की लेवल बढ़ रही है। मेन आके फंस जाता है आदमी यहाँ जाते गलती कर देते हैं, हम लोग करते हैं। तो इसका नेगेटिव बनेगा, am I not working, समझ में? इस स्टेप में आपको नॉट ऐड करना है, जैसे यहाँ पे आपने किया इज ही नॉट गोइंग, आई नॉट गोइंग, इज ही नॉट वर्किंग, आई नॉट वर्किंग। इस टाइप में नेगेटिव सेंटेंसेस आप बनाएंगे। इंग्लिश में यही चीजें इंपॉर्टेंट होती है। एक तो रहता है पॉजिटिव सेंटेंस, दूसरा रहता है नेगेटिव, तीसरा रहता है इंटरोगेटिव क्वेश्चन, क्वेश्चन पूछते हैं आप, राइट? हमने सिंपल प्रेजेंट देखा, प्रेजेंट कंटिन्यूस देखा। अब आते हैं हम लोग सिंपल पास्ट पे। ये भी इंटरेस्टिंग है, सिंपल पास्ट। सिंपल पास्ट टेंस, सिंपल पास्ट टेंस। सिंपल पास्ट टेंस का आपको सबसे पहले तो फॉर्मूला लिखेंगे हम सिंपल पास्ट का। कैसे बनाए? सब्जेक्ट प्लस V2। देखो यहाँ पे चेंज हो गया, अब ये ध्यान देने की चीज है, ये तो V2 है, ओके। और परफेक्ट में जब चले जाएंगे तो V3 हो जाएगा। और और जब चेंज वाइज भी करेंगे ना, तो पास्ट पार्टिसिपल यूज करेंगे हम वहां पर पैसिव वॉइस में। तो ये चीजें एक एक वर्ड मेरा अच्छे से ध्यान दो, आपको समझ में आ जाएगा। सिंपल प्रेजेंट टेंस में क्या था? यहाँ पे V1 था, बाकी सब सेम था। यहाँ पे सिर्फ V2 हो गया। अच्छा, V1 V2 V3 V4 और V5, इसका एक टेबल आता है। जैसा मैं आपको यहाँ पे टेबल दिखाता हूँ, दिख रहा है ये टेबल, दिख रहा है ये टेबल। प्रेजेंट, पास्ट, पास्ट पार्टिसिपल, प्रेजेंट पार्टिसिपल, मतलब जो इसको हम लोग जनरली V1 V2 V3 बोलते हैं। V1 V2 V3 V4 और V5, मतलब जब लगा रहता, ओके। जब S लगा रहता उसको हम V5 बोलते हैं। तो ये आपका पक्का हो जाना चाहिए। इसमें बहुत गड़बड़ी हो जाती है, इसी में स्पेलिंग मिस्टेक भी हो जाती है। फिर ये पूरा लिस्ट दिया है नीचे तक, हम आपको दे देंगे, ओके। और भी इसमें वर्ड्स ऐड करूंगा मैं, और वो फॉरवर्ड करूंगा आपके पास। किसी को ऐड वगैरह तो नहीं करना है, ओके। चलो एक सेंटेंस बनाते हैं हम लोग इसका, सिंपल पास्ट टेंस का। ही गो का फॉर्म आ गया वेंट, ही वेंट टू ऑफिस। दे प्लेड क्रिकेट। नेगेटिव में कैसे सेंटेंस बनाएंगे हम लोग? शी डिड नॉट, आ गया डिड नॉट, इसको डिडंट बोलेंगे। शी डिडंट ईट। देखो यहाँ पे एट नहीं किया, इसको नहीं चेंज किया, अब ये V2 में नहीं है, ये सिंपल V1 में है, ठीक है, क्योंकि इधर डिड आ गया। ब्रेकफास्ट, वी डिड नॉट वॉच द मूवी, ओके। एक चीज आपको समझ में आना चाहिए, जो दिखी भी रहेंगे आपको, कि जब जब निगेटिव सेंटेंसेस आ रहे हैं, जैसे कि ये निगेटिव सेंटेंसेस, तब तब V1 यूज हो रहा है, राइट? जब जब निगेटिव सेंटेंस रहेगा ना, तो V1, क्योंकि निगेटिव सेंटेंस बनाने के लिए ये सिंपल पास्ट में मैंडेटरी है कि डिड का यूज होना चाहिए। डिड के यूज करे बगैर आप निगेटिव सेंटेंस बना ही नहीं सकते। जब आपको नेगेटिव सेंटेंस बनाना है, आपको डिड यूज करना ही पड़ेगा। देखो ये नेगेटिव सेंटेंसेस का बॉक्स सिंपल पास्ट का दिख रहा है, ये V1 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 V1। क्योंकि निगेटिव आपको बनाना है तो आपको डिड लगाना ही लगाना है, और जब डिड लगाएंगे आप तो V2 ले ही नहीं सकते, मतलब V1 ही लेना पड़ेगा आपको, वर्ब का पहला फॉर्म ही लेना पड़ेगा। इधर देखो, ये वी का दूसरा फॉर्म है, ये दूसरा फॉर्म है, ये दूसरा फॉर्म है, चला कोई इशू नहीं है, क्योंकि पॉजिटिव में आप कर सकते हो। लेकिन निगेटिव में जब व्हेन यू आर ट्राइंग टू मेक अ सेंटेंस नेगेटिव इन सिंपल पास्ट टेंस, you are ought to use the word did, and when you use the word did, then you must use the word uh, in its uh, in its first form, okay, in its root form, okay. So I think we have completed 3 to 4. Yes, Prakash, do you have question? You raise your hand.
Sir, I want to say we should skip this part, sir, because it's very easy. Everyone,
Ah,
I think everyone know about this.
okay, no, but अगर कोई
And
ऐसा है
we
जिसका,
have only,
yes,
sir, we have only 14 days.
yes, I know, we can
So,
complete.
sir, we should focus on that part that are really tough.
Okay, ये let us talk to others as well, कि कितने लोगों को इशू है, अगर किसी को इशू है तो उसको मटेरियल डिफरेंट सेपरेटली भेज कर किया जा सकता है फिर। कोई
Yes,
ऐसा
sir.
मतलब नहीं, देखो एक बच्चे 2 टाइप के रहते हैं और फीस सबने भरे हुए रहते हैं, तो अपने को ये देखना है कि ऐसा कोई है क्या जिसको अगर टफ मतलब किसी को वीक है किसी का इंग्लिश, फॉर एग्जाम्पल कोई रूरल एरिया से, उसका इंग्लिश उसका बेस, अगर उसको टेंस नहीं पढ़ाएंगे तो शायद उसको आगे फिर उसका सब मतलब वीक रह सकता है, क्योंकि आगे तो हार्ड पॉइंट्स है ही, क्योंकि इडियम्स, फ्रेजेस, टेंसेस, डिग्रीज, सेंटेंस कंप्लीशन, प्रीपोजिशन, पार्ट ऑफ स्पीच, ये सब करना है। तो प्रकाश ने जो बोला उसके अलावा किसी को कुछ बोलना है, डिसेंटिंग वॉइस किसी का, कि हाँ सर थोड़ा, मैं इतना करता हूँ कि कल फिर टेंस खत्म कर देता हूँ प्रकाश, फिर अपना ये भी हो जाएगा,
Yes, sir.
हाँ, कि बाकी
Yes,
के
sir.
कभी किसी का तकलीफ नहीं होगा और तुम्हारा भी प्रॉब्लम सॉल्व हो जाएगा प्रकाश, ओके।
Okay,
कल,
sir.
Okay,
हाँ प्रकाश, हम क्या करेंगे आज, जैसा कुछ पार्ट किया क्योंकि आज दूसरी भी बात हुई, तो हम कल लेकिन टेंस को फिर कैसे, बाकी के बच्चों को जिसका टेंस में कुछ पॉइंट्स वीक रह गया उसका भी क्लियर हो जाएगा, और फिर थर्ड लेक्चर से हम लोग डेप्थ में भी जाना स्टार्ट कर देंगे, चेंज द वॉइस के, ओके दैट।
Okay, sir.
yes, sir.
हाँ ठीक है, और मैं मटेरियल भेज देता हूँ पहले, जिसको कुछ भी टफ लगता है उसके पास मटेरियल
Yes, sir.
रहेगा, मैं सब कुछ अपलोड कर दूंगा। मैं सीटी का सबसे स्कोरिंग पार्ट है, सबसे इजी भी पार्ट है, सबसे इजी। और मैं इसके अलावा भी एक चीज एक बोलूंगा कि आप लोग है ना, जीके को उतना ज्यादा फोकस करो मत, ठीक है, कि जीके का क्या पूछेंगे इसका कुछ फोकस नहीं किया। बहुत सारे बच्चे लोग है ना ज्योग्राफी पढ़ते बैठते वगैरह वगैरह, बहुत कम क्वेश्चन आते हैं, बहुत कम क्वेश्चन आते हैं। और करना है ना तो क्या करो, मैं बता दूंगा नेक्स्ट लेक्चर में उसके बारे में भी, जीके के बारे में कि क्या करना है। अच्छा, फिजिक्स केमिस्ट्री बायो के, फिजिक्स केमिस्ट्री के बारे में भी क्या खास है, तो उसका थ्योरी का पार्ट ज्यादा फोकस करो, थ्योरेटिकल क्वेश्चंस ज्यादा पूछते हैं लोग, ठीक है। अभी तक का जो एक्सपीरियंस रहा हमारे ये स्पॉन्सरशिप के क्वेश्चन एग्जाम्स में भी करीबन करीबन 12-15 एग्जाम्स हम लोग देखते हैं, जो अभी रिसेंटली जो फेमस है, इनके 12-15 पेपर्स मैंने देखा है खुद, बच्चों से मैंने कंसल्ट किया। इस साल के भी अभी 7-8 पेपर तो हो गए इस साल के, आप लोगों को पता होगा जिसने दिया है, 7-8 पेपर्स ऑलमोस्ट हो गए, लास्ट ईयर के भी हम लोग ने देखे थे। तो उसके बारे में भी मैं बात करूंगा नेक्स्ट लेक्चर में, आई थिंक 4 मिनट एक्स्ट्रा हो गए, सो आई विल स्टॉप इट हियर। Tomorrow I will be talking about the GK section also and the strategies that we should use to clear this exam with good rank, at least below 500 के आसपास अपनी रैंक आना चाहिए, ठीक है, उतना टारगेट रखो, आप 500 से अंदर ही आना चाहिए, उससे आगे जाके
Okay,
कुछ भी
sir.
फायदा नहीं। अच्छा, टफ कंपटीशन बढ़ रहा है, टेलीग्राम की वजह से, यूट्यूब इंस्टा की वजह से, है ना, इंफॉर्मेशन रीच कर गई है। ये
Yes,
पहले
sir.
ऐसा होता था कि आईएमसीटी किसी को नहीं पता पता रहता, 15-20 हजार बच्चे एग्जाम देते थे सिर्फ, लेकिन ये नंबर बड़ा है, और आप बिल्कुल भी कैजुअल मत लो चीजों को, ठीक है। मैं आपको बोल रहा हूँ इस साल से पेपर की जो लेवल है या कंपटीशन पर्टिकुलरली ये बढ़ेगा, क्योंकि ये जो एवेन्यूज है, लोग फेडअप हो गए दूसरी चीजों से, इंजीनियरिंग से, मेडिकल से फेडअप हो गए, और लोग बल्क में इधर आ रहे बिल्कुल।
सर 82,000 स्टूडेंट रजिस्टर्ड
वही
टिल
तो
नाउ।
मैं बोल रहा हूँ, क्योंकि हम जब स्टार्ट करते थे पढ़ाने को तो कितने बच्चे थे, मैं आज से कुछ साल पहले की बात कर रहा हूँ, 12,000 15,000 स्टूडेंट होते थे बस, और हर दूसरे बच्चे का सिलेक्शन हो जाता था। लेकिन ये कंपटीशन ट्रिमेंडस बढ़ा है, ट्रिमेंडस। ओके, मतलब आप इमेजिन नहीं कर सकते, इसलिए जितना टाइम बाकी है आप सब सोशल मीडिया को वगैरह सब छोड़ दो, जितना कुछ है ना फुल फोकस, इवन मैं तो ये भी बोलूंगा आईपीएल वाईपीएल भी छोड़ दो, लेकिन आपको अगर अच्छा कॉलेज सच में चाहिए ना, खास करके लड़कियों के लिए वगैरह, लड़कियों के लिए तो गोल्डन अपॉर्चुनिटी है, गोल्डन अपॉर्चुनिटी, मतलब आप लोगों को बहुत 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 ज्यादा स्कोप है। ठीक है, और मैं कल भी एक बात करूंगा मेरे पिछले 7 8 साल के एक्सपीरियंस में कि ये एग्जाम कैसे इवॉल्व हो गए, तो आपको आइडिया आ जाएगा कि कैसे कैसे करना है। लेकिन फिलहाल अभी सेल्फ स्टडी पे ज्यादा फोकस करो, अभी जैसे लेक्चर खत्म हो रहा है, पढ़ाई पे फोकस करो, मॉक पेपर्स पे फोकस करो, और तुम देखेंगे कि रिजल्ट आएगा, ऐसा नहीं कि नहीं आता है, रिजल्ट रिजल्ट आता है। टारगेट रखो, फिक्स करो, और उसी के अराउंड पढ़ना स्टार्ट करो, कैजुअली मत लो। बहुत सारे होशियार बच्चों का प्रॉब्लम ये है कि वो कैजुअली लेते हैं चीजों को। डू नॉट टेक थिंग्स फॉर ग्रांटेड, दिस इज व्हाट आई कैन से यू। I know that you are talented. I know that you can work hard, but just put your efforts and don't let things go casually. Okay, I think I will stop it here. If you have any question, you can be asking tomorrow. Tomorrow
सर
will,
एक क्वेश्चन पूछना था।
हाँ, yes.
सर क्वालिफाई करने के लिए कितने मार्क्स लेना पड़ेगा?
क्वालिफिकेशन क्यों चाहिए आपको?
नहीं
आप
सर, मतलब बिलो 10,000 रैंक चाहिए तो।
नहीं, मतलब कैसा होता है, देखो कॉलेजेस बहुत सारे हैं, तुम एक बात को समझो, कॉलेजेस बहुत सारे। अभी इसके अंदर डिपेंड करता है, आप डीएनएस कर रहे हो, बीएससी कर रहे हो, बीटेक कर रहे हो, ये बहुत सारी चीजें डिपेंडेंट रहती है, और कॉलेज किस टाइप का है, और उसके ऊपर जा रहे हम लोग। तो एक तो सिंपल सी बात है भाई कि हम लोग वहां पे जा रहे पैसों के लिए, ये मतलब ये तो है, अपार्ट फ्रॉम एडवेंचर, हमारा करियर हम लोग बना रहे हैं, हमारे करियर के ग्रोथ के लिए हम लोग जा रहे हैं। तो ऐसे कॉलेज में जाना ही क्यों है जहाँ पे पता है कि जाने के बाद हम स्टक होने वाले हैं। तो आप ऑब्वियसली, अगर आपकी रैंक कम आ जाती है, इवन इफ यू आर क्वालिफाइंग, इमेजिन इवन इफ यू आर क्वालिफाइंग, अगर आप स्टक हो जाते हो तो कुछ मतलब नहीं है ना, फिर इतना फीस भर के उसका कुछ मतलब रहता नहीं। तो मेरे भी हिसाब से तो आप तो टॉप का ही सोचो, क्योंकि इतना एग्जाम टफ नहीं है वीजा वी, जैसे कि एनडीए है, जैसे कि एमएसटी सीट है, जैसे कि जेई है, उतना टफ कुछ क्वेश्चंस नहीं आते ना, उतना उसको क्वालिफाई करना मुश्किल है। तो आई विल नॉट गो फॉर दैट।
नहीं सर, क्योंकि आप
सर आई
एक
हैव वन क्वेश्चन।
बोला कि
हाँ
80,000 लड़के हैं ना।
हाँ, एक मिनट बोलो।
सर मतलब
सर
80,000
साइन।
लड़कों में सिर्फ 15,000 लड़कों को ही क्वालिफाई करते हैं।
हाँ,
तो सर मतलब क्वालिफिकेशन के लिए भी कंपटीशन है ना बहुत।
हाँ कंपटीशन है, ये कैटेगरी 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 भी वेरी करता है। हाँ बोलो, नेक्स्ट, किसी का प्रकाश कुछ बोल रहे थे या? हाँ,
सर साइनोनिम्स और एंटोनिम्स पार्ट के लिए क्या करें सर, क्योंकि ये बहुत वास्ट है।
नहीं नहीं, इसके है ना, मेरे पास नोट्स है, मैं आपको दिखा दूँ, मेरी स्क्रीन विजिबल है ना, मेरे पास नोट्स है इसके, इतना ही करो आप। मैं आपको ये बता देता हूँ, देखो ये मेरे पास ये नोट्स है, ब्लैक बुक है पूरी। ठीक है, ये कुछ इसके अंदर सब कुछ दिया है, सिनोनिम्स एंटोनिम्स आप देखेंगे ना, फॉर एग्जांपल ये, तो एक साइड में सिनोनिम, एक टाइप में एंटोनिम्स, सब कुछ दिया है, दिख रहा है, ये मैं आपको शेयर कर दूंगा।
सर तो आप हमें
यस।
बुक सेंड कर दो पीडीएफ।
हाँ 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 बिल्कुल, ये सब मटेरियल आपके पास आएगा, डोंट वरी। ऐसा नहीं है कि मैं स्क्रीन पे दिखा रहा हूँ आपको भेजूंगा नहीं, पूरा मेरे पूरा फोल्डर ही मैं अपलोड कर दूंगा।
ओके सर, थैंक यू।
यस, और जैसे भी
सर
कुछ नया लगता है मैं अपलोड कर दूँ। ठीक है, शैल आई स्टॉप इट ना?
यस सर।
यस सर।